Well, hi, it's me, Tim Dodd, the Everyday Astronaut. I'm back home, and just in time for my favorite rocket company's Black Rocket. I'm gonna go ahead and say that Rocket Lab is. I don't pick favorites, actually. I don't pick favorites. I love Rocket Lab, though. If you don't know why Rocket Lab is awesome, I made a video like a year and a half ago, about a year ago. I definitely need to update it because they're just freaking awesome. The Electron is like the coolest little rocket ever. So we're going to, of course, start off like we always do and do one of these where we go to this website called everydayastronaut.com. Then you can click on pre-launch previews right here, la-di-da. And when you do that, you'll see all upcoming launches. And we try to write an article about a week ahead of time that will give you a rundown. So I know people always get on Twitter right away and be like, Tim, when's this? What's this? How is this? Normally, most of the things you're asking are right here in the pre-launch preview. So let's run through this real quick. So this is scheduled to take off on March 21st, which is, oops, we need to update that. My bad. That is a manual thing, but really it's supposed to be taking off here. Oh, I also need to make sure that my countdown clock is on because look at this. Oh, it did that thing where it's the wrong size. Can you tell I haven't been here for a second? Hold on. Let me do this. Sometimes this. I know the tricks, OBS. You can't fool me. So that's how much time we have left facing until they're gonna launch. Anyway, so the rocket's gonna take off in 25 minutes. This is the radio frequency risk reduction deployment demonstration, R3D2, which I can't help but say R2D2 every single time I even see anything close to this. I'm immediately like, oh yeah, the R2D2, of course. And this is actually really cool. We'll talk about it more in a second here. But of course, this company launching it is Rocket Lab. The people paying for this is the United States' Defense Advanced Research Projects Agency, or DARPA, which you may have heard of. Pretty big deal, actually, that Rocket Lab's already launching something for DARPA. They're launching it on their Electron rocket, which is the only rocket they currently produce. The launch pad location is Launch Complex 1 on the Mahia Peninsula in New Zealand. So yes, this launches from New Zealand, which is awesome. It's easily probably one of the most beautiful launch sites in the world. This is a pretty light payload because, again, the Electron is tiny and it can't launch a huge amount. Its total payload mass is about 225 kilograms. So what is that, like 400 pounds or so? This is 150, that's like 465 pounds or something. This is 150 kilograms, so it's not even really pushing it too hard. This is going out to low Earth orbit. I believe it's going to like a 425 by 425 orbit. Yeah, so it's 425 kilometers by 425 kilometers, I think. So standard low Earth orbit, no big deal. The first stage of the Electron is not recoverable. And I don't have anything that says otherwise. I've never heard a word for, even though I know people that work at Electron or at Rocket Lab, but I've never heard anyone say that they're working on recoverability or anything. But I would not be surprised if this company soon, at some point, pursues. I know Peter Beck has said in some interviews that he's excited about this year. They're going to work on some block upgrades and just kind of slowly making tweaks. And he's got some exciting things planned. I know it won't be a bigger rocket because they're very adamant about not building a bigger rocket. But I wouldn't be surprised if they start toying around with some interesting concepts. They are just one of those companies that likes to push the boundaries. So it wouldn't surprise me at all. And don't forget, one of the reasons that they currently don't have recoverability is they're already, they can only put 225 kilograms into orbit. Imagine if you had to save some of that fuel and all that stuff to be able to do a propulsive landing, like your payload mass would be zero. Like you'd end up with, you'd not be able to put anything into space. So as the vehicle stands today, it really doesn't have the margin to do any kind of recoverability, at least for the market. So maybe someday they'll figure something out, but who knows? I wouldn't plan on it. But maybe. Where will this land? Of course, it's going to crash into the ocean. They do not attempt to recover fairings. This will be the 5th launch of the Electron, the first launch for Rocket Lab this year. And then, of course, we have Jeff Barrett's beautiful illustration here as well, which kind of gives you the whole rundown. So, yeah, I hope that gives you the rundown. This is the actual R3D2 satellite, which is really cool. The reason that I think this is neat is this is taking that whole, like, let's make tiny satellites do what traditionally huge satellites have done in the past. So DARPA is looking at, taking this is a small satellite. Like, you could almost, a pair of people or 2 people or 3 people, pretty strong people could pick this thing up and move it around. It's not that big. And yet it's going to have this demonstrator that's working on, like, an advanced antenna membrane, like this really thin, here, actually check this out. I think I've got their, so this is the actual press kit from Rocket Lab. So yeah, it's tissue thin Kapton, however you say that, this word, the one with the K, I don't know. Kapton, I've heard it say, I can't talk though. Kapton membrane, and that all folds up into this cute little demonstrator. It's just a really, I love the idea of something small being really powerful. Something that used to be reserved for a very large satellites now being done on a tiny little rocket that's inexpensive and readily available. I think that's really cool. Yeah, so this is also a cool timeline of events. So we are at T-minus 20 minutes. So we're coming up probably at T-minus 18. The launch director conducts a go, no-go poll. So while we wait for that, I'm going to make sure I have the live stream. Their live stream is going to be up in about 3 minutes. I'll get that over there. I made it back, guys. I drove almost 4,500 miles. What is that in kilometers? That's like, 7,000 kilometers or something in the past 10 days or so. I drove out to Moab, drove down to Brownsville, Texas, and stalked the Starhopper for fun. That was a good time. I had a good time just kind of hanging out there. Come to find out, that area is actually pretty cool. Who knew? And yeah, I can't wait to watch that continue to develop too. So Kumquat Lord, thank you. Hey, Tim, recently learned that my company helped make the titanium solar panel hinges on Spirit and Opportunity. How cool is it? That is actually really genuinely cool. I didn't help with it. I was only 2 or 3 at the time. That is actually really cool, though. I wish that I worked for a company that had done something with Spirit and Opportunity. Two of the greatest, you know. Um, yeah, those are some of my favorite rovers. And Aaron Speck, thank you. Yeah, so I think, let's see, we are 2 minutes from the thing. So hopefully we're getting a poll here really soon. Oh, it looks like I don't have the countdown clock up on here either. Okay, that'll probably be any second. Meanwhile, I'll pull this back up so you guys, if you have any questions about this stuff, let me know. Don't forget, guys, this rocket is some of the coolest things about this rocket. The engines are 3D printed. They literally, every bit of the engine is 3D printed. They're powered by electric motors. So they have very insanely powerful, it's about the size of a soda can, the motors. And they're as powerful as I would want that on a motorcycle because I believe it's like over 100 horsepower. They're crazy powerful little motors. And then they have very powerful lithium-ion battery packs. The rocket's also made entirely of carbon composite, which no other operational rocket has ever used. Carbon composite fuselage and tanks entirely, and electric motors. I mean, this thing is, and the 3D printed engines, it ticks off like 3 of the coolest boxes in all of the rocket world right now. That's one of the things that I just love about this rocket. They're doing things super different, and they're doing things like, think about how relatively simple running a rocket engine using electric pumps is. I mean, you don't have to worry about, you don't have to worry about all these crazy valves and pre-burners and staging of this, and this to get it to do the thing. You just go, turn on a switch, basically, and there it goes. Pretty slick. And that's why this thing, I think once they're still a relatively new company. This vehicle's only been flying for about a year. And once they really get the kinks worked out, I have a feeling their big thing is going to be cadence. They already have like 6 of these things manufactured, ready to go out the door. So as soon as they really figure out their systems in place, get ready to just see them going boom, 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 just launching these things all the time. And the other thing that I think is great is they're very good stewards of space. So you'll see that they never leave space junk in space. I think that's really smart. So they deorbit everything. Let me see if their live stream is ready. It is not yet. Just checking in. Yeah. So I think that's cool. So everything gets deorbited, including the kick stage. So it's almost like you could almost think of it as a 3-stage rocket. They have this little thing called the Curie upper stage, which maybe they have a picture of, that is inside the payload fairing that will actually help precisely maneuver. And especially like, say you have different payloads on slightly different inclinations and different things like that. It can just kind of help do some of that work ahead of time. If you have a bunch of CubeSats, I just think that's really cool. It runs on the engines they use are called the Rutherford engines. And there's 9 of them on the first stage. It's basically it is like a baby Falcon 9 rocket. Oh, here's the Curie kick stage. And the fact that it is 9, it isn't really anything to do with SpaceX having 9. It's really nothing like that. It's really a matter of scale of economics. So you have the ability to, make a bunch of small engines. It's the same philosophy. I mean, it totally makes sense. Produce a bunch of small engines so you can pay off, if you're producing 9 times more engines than a rocket that only has 1 engine, think about how much quickly you pay off that research and development, how much quickly you pay off the equipment, how much easier it is to physically manufacture a bunch of small engines than one big one. You can pick that thing up with your hands. It's a small engine. It's really cool. I think, to me, it's really smart. Then they have a single vacuum optimized version of that same engine on the upper stage. So again, very akin to the Falcon 9. And yeah, this is that Curie kick stage. It runs on some kind of green monoprop that they won't tell us about. But that's okay. Let's see. Tim Burton in our Tim Botron, not Burton. Hey Tim, how are you? I haven't seen you. Welcome to our Discord. Am I planning to go to the Cape for Falcon Heavy? Yeah, I am. I am planning to go. I think I'll be leaving next Friday. I'll probably fly down for this one. And I'll maybe do a bit of a stripped down thing. I'm going to maybe try, I need to finish up talking to Das Valdez, who has streaming backpack solutions. But I am definitely going to attempt to probably run one of his streaming solutions that hopefully I have a really, really good streaming solution. Can bring you guys some really good coverage from the Cape instead of I did okay at DM1. I definitely messed some stuff up still at DM1, and that was a pain in the butt. I hope that we can get a really simple, reliable, clean solution here for you guys. Mary Smith says, welcome home, Tim. Hope you had a good getaway. I'm excited for the launch. Keep doing what you do. Thank you very much, Mary, and hi. Footy Nut Guy sent him to space. Nah, I don't know. Three-sided coin. Stewards of space, yes, but what about stewards of the ocean? They are throwing a lot of carbon fiber into the ocean. That's a good question, three-sided coin, and I'm going to be doing a video all about how much do rockets pollute. And believe it or not, you know, the amount that a rocket pollutes and the occasional carbon fiber core being, you know, I wonder what that does in the ocean. I know that a lot of the aluminum and some steel parts that are in rockets, traditional rockets, they actually, they actually attach them to, coral, like, will actually attach itself to the fuselage because they have all these, like, holes in them and stuff. And they even build some vehicles, depending on, like, where it's going to be for coral and for marine life, so that it actually isn't, like, a bad thing when it falls into the ocean. I would imagine that carbon fiber actually would break up pretty quick. And I don't know. I don't know that much about that. That's really why I want to do a deep rundown on how much do rockets pollute and talk about all the aspects, including obviously air pollution, but water pollution as well. I think that it's going to be a really good video. One of those things that I'm excited to really dive into, because that's one of those things that I hear a lot about and don't actually have the answers myself. So I'm also going to pull up Twitter and get Rocket Lab up here so we can kind of keep an eye in case they have any changes here. Because let's see, Mr. Muskrat, hello. Somewhat unrelated, but why would SpaceX do a pre-burner test or something for like an hour the other day? So that's Mr. Muskrat. So think about it like this. They're doing literally one step at a time. This is an entirely brand new vehicle. And think about how many systems there are just incrementally. If they strapped the Raptor engine onto Starhopper and immediately fired up and immediately something blew up right away, think about all the variables they have in place that have to be like, oh shoot, was it the pre-burner? Was it the, you know, LOX inlet, or was there an overpressurization event in this or that? Or like, think about there's so much stuff going on in that engine that I can't even begin to imagine. So they're literally just going one step at a time. Oh, now we'll do this. Okay, now we'll try this one. Okay, now we'll fuel this one. Now we'll run this line. Now this line. And every time you do that to eliminate variables, you go one step at a time and make sure that in doing so, you know what's going to happen, you know, and you have confidence moving forward that the system that you just tested out was within your constraints, within your design constraints, and working well. So, yeah, it might seem like a bit frustrating, but normally you don't see this from a rocket company. You normally don't get to sit there and watch them physically from 1.5 miles, 2.4 kilometers away, and be like, oh, I wonder what part of the startup process we're looking at here today. Because normally that stuff's like super behind closed doors, often like an Air Force base or, ooh, their live stream is going. Let me pull this up here for you guys. You know, so normally you don't get to see that. So, yeah. Christopher wants to know if I'm going to Yuri's night in Los Angeles. Unfortunately, I don't think so, because I think Falcon Heavy is going to interrupt that. Okay, let me get this up here for you guys. Yes. Excellent. See, one of the other fun things about this rocket is when we see it like this, it's black, and then when we see it on the pad, it'll be half black, half white, and that's because ice and condensation, like that. Look at that, half white, half black. That's ice on the fuselage. I think that's super cool. That always is entertaining to me. Yeah, those are some good questions. Also, thank you CGG10 and Ian Chase. As always, thanks for what you do, Tim, and welcome home. I know it was a long trip, even in a Tesla. It was a long trip, but a good one. All right, let's listen in here.
Hello and welcome to the live broadcast of Rocket Lab's 5th Electron launch, the R3-D2 mission for DARPA. We are currently sitting at T-minus 11 minutes from target liftoff. The weather is looking green, and we are ready to launch this mission to orbit. My name is Max Muncy. I'm part of the mission operations team here at Rocket Lab, and I am coming to you live from Mission Control here in Auckland, and I'm so glad you could join us to watch yet another Electron launch. What you're looking at now is a live view of the Electron rocket on the pad at Rocket Lab's Launch Complex 1 on New Zealand's Mahia Peninsula. We've got microphones down there so you can hear the final stages of launch operations, and if you're lucky, you might be able to hear some of the local birds as well. Launch Complex 1 is the world's only private orbital launch site in operation. Operating our own launch site gives us an enormous amount of freedom and flexibility to launch frequently and on our customer schedules. This is important because launch frequency is key to providing better access to space for small satellites, and with Launch Complex 1, we can fly up to 120 missions each year from the same pad. Earlier we had confirmation in the final poll that we are go for launch.
That's good. I'm ready for this.
Today's mission is an exciting one, as it's our first mission for the Defense Advanced Research Projects Agency, or DARPA. This flight is a dedicated mission for the agency, which means one microsatellite weighing around 150 kilos is the sole payload on board. Electron was designed exactly for the size of this spacecraft. By offering a dedicated ride to orbit for satellites in this 100 to 150 kilo class, we can provide small spacecraft customers with frequent launch opportunities, scheduling freedom, and precise orbital insertion. The spacecraft on board Electron today is called R3D2, and this stands for Radio Frequency Risk Reduction Deployment Demonstration. This mission intends to space qualify a prototype reflect array antenna to improve radio communications in small spacecraft. So we have a short video from DARPA which explains more about the payload and its mission.
Of course.
R3D2 is the RF Risk Reduction Deployment Demonstration. And what we're doing on this mission primarily is demonstrating a new high compaction ratio deployable antenna. So an antenna has a lot of different uses for DoD. One example is communication. The antenna and the power you have in the satellite dictates what size of antenna you need on the ground to receive it. So the bigger the antenna you can have in space, the smaller the one can be on the ground. Fitting that very big antenna into a smaller satellite makes the satellite less expensive and allows us to leverage different types of launch vehicles that maybe we wouldn't be able to use for bigger satellites. So once it reaches orbit, the first thing we try to do is gain communication with the satellite. Once we've done that, we'll deploy our solar arrays, and then the small container on the top of the satellite is where the antenna is housed. So it has 4 different carbon fiber deployment mechanisms that will go out on each corner. And then it has a pantograph, which is a shape that kind of looks like an accordion, around the outside that will expand. And then we will begin to see how flat the antenna is. We'll do some assessments from the ground to see what it might be able to transmit. And what's really making the antenna work is the copper etchings on top of the kapton. So kapton looks a lot like cellophane you might have in an Easter basket. And so it's a great place to hold the copper, which is what is reflecting the energy. And it's just set into the kapton. And so when electromagnetic radiation hits the antenna, it acts like a parabola and focuses that energy instead of acting like a flat plate.
That's so awesome. See, that kind of makes me excited. That type of stuff, definitely new.
And there you have it. We are incredibly excited to have R3D2 aboard Electron today. The R3D2 spacecraft will mark the 25th satellite deployed to orbit by Rocket Lab. We had a busy year in 2018 with 3 orbital Electron launches, and those launches saw us deploying a variety of commercial and government payloads to orbit. We are in March already, so it feels good to be back in the pad for the first mission of 2019.
I love that the logos are in the RP1 section and the interstage where there's not that ice buildup. The ice buildup is around the oxygen tank. Liquid oxygen is extremely cold, like colder than minus 200 degrees Celsius, or around 200. I think it starts liquid at like 180 or something, 170 Celsius, minus 180.
Right now, R3D2 is scheduled to deploy from Electron's kick stage at around 53 minutes after liftoff. Due to the position of the spacecraft at the time of deployment, we won't have live video feeds, so we'll be ending today's webcast after separation of the kick stage. If you want to know how things are going, make sure you keep an eye on Rocket Lab's social media channels for confirmation of payload deployment.
Matthew Wilson has a really good question. I thought that DARPA had to work with U.S. companies. Isn't Rocket Lab based out of New Zealand? They're kind of interesting. They're actually legally based out of the United States-ish. They build the avionics and the engines in the United States.
This year is going to be a busy one for Rocket Lab, building and launching rockets every month. Frequent launch has always been the goal here at Rocket Lab, and we spent much of the past year scaling our facilities to support rapid manufacture and launch. Currently, our team is building an Electron every 30 days to support this launch cadence. From day one, every aspect of Electron was designed for rapid manufacture, including the 3D printed Rutherford engines, the fully carbon composite rocket bodies, and even the payload integration system. Our customers have the freedom to integrate their satellites on-site at the launch complex or at our headquarters in Huntington Beach, California.
Stage power locks down and FTS powers down.
Thank you, Asio. FSO flight mission.
Go ahead.
I can confirm the FTS is on internal power. Check tone should be up continuously from now.
Copy.
Please enable the FTS failsafe and confirm.
Failsafe enabled. Confirmed.
FTS flight mission.
Go.
Confirm FTS is green and on internal power.
FTS is green and on internal power.
Thank you.
Flight termination system, not a
Okay,
bad
all
thing to have.
stations, this is flight on mission cord. From now on, there should be no red flags on your LCCs.
I love their accents. Genuinely.
Flight
do.
mission cord.
Go ahead.
RCO. Range is green, auto sequence armed.
Copy, thank you. FSO flight mission.
Flight safety is green.
Thank you.
So yeah, so they're kind of like a weird hybrid of a US based company, but also based out of New Zealand. So it does get a little bit confusing. So, yeah, it is very confusing when you have that, but it allows them to do missions for NASA and missions for DARPA and things like that. So pretty cool. They also, don't forget, are actually developing and building currently right now a launch pad in the United States at Wallops. So that will be, I believe that's Launch Complex 2, I believe they call it.
Avionics flight mission cord.
And I can't wait, that's
Please
out of
disable the
Virginia.
HVAC heaters and confirm.
HVAC heaters are disabled.
And please disable the HVAC heater fans and confirm.
Heater fans are disabled.
LD flight mission cord.
Yes, flight.
I can confirm the vehicle's ready for flight.
Copy.
And for those of you saying that I have bad volume and stuff, I did change it around now. I boosted myself about 6 decibels.
Now, as we hit T-minus 3 minutes, let's turn over to mission control audio and follow the remainder of the count.
That's their launch control right there in Auckland. It's beautiful. I was lucky enough to go there I don't remember when that was, like October, November, sometime, and it was absolutely gorgeous. Such a cool
Flo,
launch
this is
facility.
flight on mission. Flo, please disable the power pack HVAC and confirm.
PMS, this is LD on mission call. Go ahead. I confirm you go for auto sequence start at T-minus 2 minutes. Copy that.
The sound you're hearing, guys, is literally birds at the
Auto
launch
sequence
pad.
locked.
That's crazy. I've never noticed that in other launches. And remember, this is only their 5th launch altogether. It'll be their 4th successful launch. Their first launch ever was actually successful, but the ground tracking station lost the second stage only like a minute or two before engine cutoff, before it actually reached orbit. And because the ground tracking station lost signal, they had to abort the mission, unfortunately. But the rocket performed perfectly up till that
Avionics
point.
flight mission cord.
Flight avionic.
Please confirm all AV bets have been switched to internal power.
Vehicles on internal power.
RCO flight mission.
Go ahead.
Confirm ground power is disabled on all 3 stages.
Power's down.
Okay, all stations, this is flight on mission cord. The vehicle is now on internal power.
Pressing locks.
So, of course, that is condensation pouring out as the vehicle vents overpressurized oxygen, and as they continue to pressurize the vehicle, that's normal. The vehicle's really cold. If you went up and touched it right now, you wouldn't be happy. You'd be hurting, honestly.
PLS flight mission cord.
Pressing carry.
Especially at those icy, the parts that are white. That
Please
is
disable the anti-geysering and confirm.
sheer ice.
Stage 1 flight mission.
Go flight.
Confirm stage 1 is pressed.
Stage 1 pressed.
Stage 2, same to you.
Stage 2 is pressed.
Fast flow wedges on.
My favorite thing
Commanding deluge on.
how we can hear the birds now, but when this thing lights, it lights so fast and so hard. It's like the most violent,
Confirm, Dilly John.
instantaneous lighting. It's so cool. You don't hear anything lead up. It just...
Readying GNC systems. Readying engines.
I'll get to you guys' questions here after this mission.
Ten, 9, 8, 7, 6, 5,
Here we go.
4, 3, 2.
Yes! Alright! Alright! Let's do this! Yeah! Oh, look at that thing!
Stage 1 propulsion is nominal.
Beginning pitch over.
Oh. Dang. Looks like it just clears the pad so quick.
As you just saw, we have had successful liftoff of the
I've been tracking
R3D2
downrange.
mission on Electron. Coming up soon, Electron will go through a series of mission milestones in quick succession, including main engine cutoff, or MECO, where the 9 Rutherford engines on Electron's first stage will shut down. Shortly after this, we'll see Stage 1 separation, followed by ignition of the vacuum-optimized Rutherford engine on Electron's second stage. Following second stage ignition, Electron's fairing will separate, revealing the payload in preparation for deployment approximately 50 minutes from now.
Dang. That thing shot out of there so fast. I love it. I love it.
Max Q.
This is maximum aerodynamic pressure. That'd be a good name for an album. Dang.
1 minute remaining.
You can see this thing steering quite a bit. Look at
Stage
that.
1 propulsion still nominal.
AOS Chatham Station.
Now notice the exhaust plume getting wider and
Contact
wider
CO2 successful.
as the atmosphere gets thinner and thinner. There's less atmosphere to push in on that exhaust gas, and now you can just see it starts to spread out further and further as the vehicle climbs
Engines
in
throttle
altitude.
down, 20 seconds remaining. Entering burnout detect mode.
Someone asked how heavy, what was this, 150 kilograms is the payload mass? Pretty light payload, but this is also a tiny little vehicle.
Stage 1 MECO.
All right, main engine cutoff.
Stage suppression succeeded.
Nice. Nice.
Ignition on stage 2, propulsion is nominal.
I
Right
love
down the
it.
center line.
Bye-bye, first stage. And don't forget that shiny looking thing you're seeing, that's actually one of the batteries. And we'll see those jettison here in about halfway through this burn. We'll see
Fairing jettison.
they actually ditch half the batteries. They do a hot swap. I think they do hot swap.
And there you have it.
There's the
Confirmation that
fairings.
Electron's main engines have shut down as planned. We've had stage 1 separation, and the stage 2 engine has successfully ignited. Electron is now carrying on to orbit.
Ferret in our Discord wants to know the rumble that we could hear. That's from ground microphones. Otherwise, we'd still hear, believe it or not, you'd still actually hear sound on the rocket now if a microphone is attached to it. Sounds does transfer through the vehicle, of course. It wouldn't transfer through air, but you can use, metal and materials to still transfer sound. So a microphone
Speed is
built
3
in
kilometers per second.
to
Altitude is
the,
150 kilometers.
you'd still hear probably a good amount of that. I love this. I love that as battery technology gets better too, their rocket's just going to get better and better, and they don't have to really do anything other than change batteries. Like, that's pretty cool. They're betting on an industry. Lithium-ion batteries is one of the most competitive.
Still nominal.
One of the most competitive industries in the entire world. So as battery technology improves, so does their rocket, and they don't even have to do anything. Let other people make the improvements in battery technology, and they just get to take advantage of that. Now I think that's pretty awesome. Imagine if they can get more power out of the batteries, or perhaps get increased capacity for less weight.
Throttle down.
It's just really cool that they're betting on they're riding on the wave of a technology that's just improving and improving and improving, with or without them. So I think that's awesome. Right now, for instance, last week I was looking at SpaceX's, actually just a couple days ago, I was looking at SpaceX's Raptor engine, try to do a fire, and you think about how insanely complicated what they have to do to eke out and it is an incredible engine.
Guidance is nominal.
Holy cow, is that thing complicated. Now imagine just being able to kind of sit back idly and be like, yeah, you guys, there we go. We got a new battery pack on the market that we can swap in here, and yeah, we just increased by 6% or something. Like, that is cool. I think that's pretty slick. So soon we're going to see the hot swap of the battery, where they ditch the first
One
set
of the unique
batteries.
features about Electron is its Rutherford engine. These brushless DC motor engines are powered by lithium polymer batteries. In a few moments, we'll be performing a battery hot swap, where we switch from 2 depleted batteries to a third fully charged battery. Shortly, we'll see the depleted batteries jettisoned to allow for a more efficient flight to orbit.
Vehicles transited successfully to safe gate.
So hopefully any second.
HV battery hot swap.
Here we go. Battery hot swap.
HV battery eject.
Isn't that cool? I just think that's really smart and really cool. And when I did an interview with the CEO, Peter Beck, when I was down in New Zealand, and he said that's actually what made it close. You say like closing the gap, kind of. That's actually one of the main things that allowed them to get this vehicle into orbit, was being able to do that hot swap of the batteries
100 seconds remaining.
At that time. That's what made it increase its payload capacity enough to make it worth pursuing. So you have things like carbon composite fuselage, hot swapping batteries. They're just squeezing every little drip of power and technology out of the thing that they can. And they're able to do it, I think, at a relatively inexpensive, and make it really inexpensive and competitive. So yes, that was the battery pack that just went bye-bye. One of the sets of batteries.
One minute remaining. Stage 2 propulsion still nominal.
Speed Piet says,
Stage 2 burnout detect mode.
Is polluting by dumping batteries smart? They are completely sealed. It's not like it's not going to be much different in the environment than it would be a rock. Again, I need to do a video all about pollution
remaining
of rockets, including air pollution and ocean pollution, marine pollution, and I'll tell you all about it. We'll figure out exactly. They study that stuff. They don't want to just but in the grand scheme of things, compared to, say, the shipping industry, which is totally different, and a lot of things get left in the ocean from that, or the garbage industry. There's a lot bigger fish to fry than a company occasionally dropping sealed up battery packs. But and besides that, yeah, Loopy's probably right. The battery packs probably burn up on reentry.
Successful transfer orbit.
Actually, they definitely would. They're almost orbital velocity. They're probably going, oh man. They're probably like almost orbital speeds.
Stage separation.
When they hit the atmosphere. So I guarantee they actually totally incinerate.
All right, you heard the call. The kick stage has now separated from Electron's second stage. Approximately 40 minutes from now, the Curie engine on the kick stage will ignite and circularize to a 425-kilometer orbit for payload deployment. Because we won't be receiving video of today's payload deploy, this animation shows what the deployment of the R3-D2 spacecraft will look like.
I love that name.
Once the kick stage reaches a precisely planned point in orbit, the R3-D2 payload will separate from the kick stage approximately 40 minutes from now. At this point, the mission will be complete. Here at Rocket Lab, we don't just go to orbit, we deploy satellites with exquisite accuracy thanks to this kick stage. The small but agile upper stage is equipped with cold gas thrusters that enable precision pointing. It means we can orient the kick stage to just the right position, then deploy our customer satellites to exactly the right orbit. So with that, we're going to end today's webcast. Thank you to DARPA and our mission partners for choosing to launch on Electron. Here at Rocket Lab, we're opening access to space to improve life on Earth, and today's mission to test new space technologies is another successful step in achieving that goal. Stay tuned to Rocket Lab's social media channels for mission highlights from today's launch, as well as confirmation of payload deployment. So wherever you are in the world, thank you for joining us today for Electron's launch. We hope you'll join us again in April for our next launch.
Sweet.
This is Mission Control Auckland, signing off.
So quick. I love it. So, yeah, hopefully that's why you guys stick around here, because now we can kind of dive into some of this stuff. I probably don't need that. We can dive into a little bit of stuff here together, talk about some of the fun things, discuss a few things here. All right, so first off, let's see here. Okay, we had a couple questions from you guys. Let's see. Where did we go? Okay, so Plastic Pinocchio asked, "Hey Tim, do you think the future of space elevators will make rockets outdated? I read that a space elevator could get 1 kilogram to orbit for less than, $100. Space elevators. I mean, of course. Of course that could make sense. There's just it's the same. It's in the same boat to me as fission. Sorry. Yes, someday. Of course. There's nothing fundamentally, of course, but it is still one of those things that's just slowly you're ticking away until you can maybe eventually get to the point where it's usable. But as soon as a space elevator is usable, that'll probably work, and that could be a huge game-changing technology, but it's not as easy. It's definitely one of those, why don't they just? A space elevator seems so easy, but when you actually start trying to develop one and start trying to figure out how you put something up into space like that, it is extremely, sorry, I do mean fusion. Yes, you're right. Sorry. It is one of those things that is just really, really, really hard, and yeah, someday that could potentially replace rockets. I'd be a little bit sad because a space elevator sounds pretty boring compared to a rocket, but it's one of those things that I wouldn't bet on anytime soon because it still requires, we're not there yet. And yeah, it'll be a while. So I love how the whole chat is just saying fusion now. Plastic Pinocchio, yeah. So thank you, Plastic. I don't know. I wouldn't bet on it anytime soon. I think we got to use what we can use now, refine what we can now, and hope that someday space elevator future comes true to the point where it does make rockets obsolete. That'd be pretty great. But yeah, Random Studios asks, what do I think of CubeSats? CubeSats is one of those things that I wasn't excited about 2 years ago, 3 years ago. I just thought who cares? But then you see a small satellite. This wasn't a CubeSat, but it was a small sat. Doing things that a big satellite can do, and you're going to start seeing more and more. CubeSats totally make sense to do a demonstration of something and do it really, really, really cheap. So I definitely would say I used to not really care about CubeSats, and now I think they're pretty cool, and I'm starting to see the value in them. Yeah, that's what I think of CubeSats, especially as nowadays people start to put reaction control systems and their own built-in propulsion. They're becoming satellites, and that's pretty sweet. Let's see. Liquid Chris, great name. Those local birds he was talking about are in for a big surprise. I can't imagine that. Again, that thing just lights so quickly and is so incredibly powerful. I would be terrified. Jeffrey Tripp, hey, he said drones aren't allowed to fly zones, but what about attaching a GoPro to a bird? Now that we could probably try. So if you wanted to get into pigeoning or whatever it's called, bird calling or whatever it is, let's try that. But then again, like what I find so funny about all that stuff is you know, even me, yes, I was sitting there trying to get a little video and some live feed of SpaceX's attempts to fuel and test their Raptor engine. But like they have way better cameras around. They have like way better equipment. And so when it happens and something cool happens, normally companies like to show that stuff off and they show us video from it. So I don't know what some jabroni like me is doing sitting in my car a mile and a half away. Kind of really like in the grand scheme of like how important and what the rocket companies are doing. Trying to like get a little drone footage with a DJI Spark is like kind of insulting compared to the work they're doing. And probably the fact that they already had someone do a really cool aerial fly around. It almost, I don't know. It's hard for me because I want that. I want to do that myself too. I want my own great footage of really cool things. But at the same time, like these companies are doing a really good job of bringing us awesome footage. So, yeah, but meanwhile, let's definitely train a lot of birds, get some GoPros. Let's start a Kickstarter thing right now. AMG Reagan, recommendations for books on math of orbital mechanics and of rocket launches. I'm fairly knowledgeable about in general, but I'm only in 9th grade. Dang, AMG Wagon, I did not realize you're in 9th grade. You've been around for a while. Thank you. As far as books actually about orbital mechanics and stuff, I don't really know if I have any really good recommendations right off the bat. I do think, what is that one? Like Buzz Aldrin's Mars Direct. No, that's Robert Zubrin's Mars Direct. Buzz Aldrin's Mission to Mars. Both of those books talk a lot about like variations on the Aldrin cycler and a couple different really cool things about that. But as far as actual books about orbital mechanics and rocket launches, I would start there on those two because those books are really good and really captivating. And they kind of get you excited and they're like future thinking. I don't know. If anyone else has a recommendation, let me know. One book about rocket engineering would be Ignition. But that's way more, I was hoping that was like literally about rocket science. It's way more about rocket fuels. And I need to probably finish that before I finish up the video I'm working on. But, yeah, dang it. I don't know. Hopefully that helps though. We'll see. Ryan Quinn, thank you. Kumquat Lord. Fun fact, the Aussie Kiwi accent comes from a drunk British accent. I want to believe that, but I don't, is that true? That sounds kind of racist almost. I don't know. I don't know what to, okay. I'll say okay. Thank you though. Ahmad Vaughn, did you ever confirm the Starhopper test we watched? So, I don't have any like actual confirmations, but like I said, we know for sure Starhopper's literally doing like spin up tests. So don't forget, like when an engine's on a stand, it's one thing, a stand that they're familiar with and use often. You can basically open up some pumps and valves and go, boom, do a test, no big deal. Now you're talking about having to fill up a pressure vessel, and they even have to like do their own onboard avionics, all these other things that are different than a test stand. So like I said, they're going one step at a time. So like LOX drop tests and all these different things, making sure that all of the different parts of the vehicle are doing the thing that the vehicle needs to do one step at a time. So I don't know exactly what happened the other day. I think it was a LOX pump spin up test. Like I think they probably fired up the pre-burner of the LOX or something, but it does seem like that was LOX. I don't really have any other information other than they're going one step at a time, and they're going to keep doing that until they're ready to actually ignite the liquid oxygen and the liquid methane. Well, actually the gaseous oxygen and the gaseous methane in the actual combustion chamber. And once those ignite, then we will have ignition. Yeah. How Apollo flew to the moon. Tim Botrin coming in handy already. I've never heard actually of How Apollo Flew to the Moon by David Woods. I have a friend named David Woods. Was it written by him? I don't think he wrote that book. I don't know. That's a cool, yeah, I haven't really heard that. Let's see. David Plant, sparks coming out of the exhaust. Is it ablative cooled? And we also see I like flying planes. Thanks to both of you guys for basically the same question about sparks in the exhaust plume. It is ablatively cooled. That nozzle after it is slightly ablatively cooled, I believe. It's, yeah, you just see some sparks coming off it. No big deal. I believe. I don't actually know for sure. Maybe some people at Rocket Lab will tell me for sure if it's ablatively cooled, but it's not. It doesn't seem to be very ablatively. It seems to be a material. I forget what. I think I actually knew what material it was at one point. But like an actively, or like a really ablatively cooled nozzle, like the RS 68 that's on the Delta, that you can tell is ablatively cooled. Like that thing shoots off a bright orange exhaust because there's so much. I already forget what it is. Every time I forget what it is, copper or something. I don't remember. Ablates off and it cools it like cools it off. I don't know if it's that type of thing or if it's just like a little bit ablates off, but I don't know. Kind of like ablation can work to different varying degrees. You know, obviously a piece of wood will ablate a lot differently than another material, like a cork would ablate a lot differently than titanium, or maybe not titanium, but any other material. You know, there's different levels of ablation at certain temperatures. So yeah, and different chemistry of that too. It's physical. Yeah. Hope that answers. A block of tungsten would probably survive almost intact. That's true. Okay, so 13 Gamer heard that countdown. They said Team 987. Yeah. So Tim, are we going back to the moon in 2024? Man, I want that to happen so bad. I think we could honestly do that. And how cool! I know that SLS and the Orion EFT1 or EM1 Exploration Mission 1 just got basically nixed the idea of it being used on commercial providers. But imagine if we actually did a 3 mission, or like a 3 commercial launch, or like even 4. Say you did 4 Falcon Heavies or something. Launched an Orion capsule, the service module, a kick stage, a lunar lander, and another kick stage. And they met up in lunar orbit and did kind of the whole thing and yada yada diddly dop. I would love that. I feel like if we really set our minds to it and said, hey, we want that in 5 years, I think we could easily do that. I think that'd be amazing. It would take funding and it would take a very strict direction, which they're getting close. Like the language up at with the administration and with Jim Bridenstine is becoming more and more clear of like, this is what we want. And they actually keep honing it in, which is refreshing. I think they have the ability to really push in and say, here's what we're going to do. We are funded for this. Please make it happen. Go. That would be great. Graphite nozzle equals ablative. Sweet. So that's my thought. Sorry, I'm just trying to... Mark Hull asks if that much steering correction was normal. So far, what we've seen of Rocket Lab, yeah, that seems to be kind of normal for them. Maybe they're still tuning their PIDs, their whatever that is, something input, something, to really make sure the vehicle does steer. But it does seem to be a little bit wobbly, but it's doing its job. They're obviously doing it well. So, Arvid says, what kind of elevator music will play in space elevators? I know of a shameless plug. There's this album called Maximum Aerodynamic Pressure that's like all about space. That'd be a nice one for a space elevator. Just saying. John, when will the SpaceX Dragon 2 in-flight abort test take place? It is currently scheduled for June, but it's, it relies on the Dragon capsule being refurbished that quickly. It relies on the booster being refurbished or checked out, I guess, that quickly. I really think they're like getting to the point soon where they aren't even needing to refurbish Block 5. They're starting to gain confidence that they can just land it and refly it and not really do like a full teardown on it. But yeah, we will see. Let's see. Yeah. So watch the Space Council meeting. VP Pence told NASA to get to the moon in 5 years. Really cool meeting. I did watch that, Zach. That's what I said. The directives is becoming a lot more clear. It's one thing to say it, it's another thing to fund it. So he made it pretty clear. Like I said, the language is becoming pretty direct, which we haven't seen in a long time. It's like, hey, really, let's just do this, which is pretty refreshing. So we will see. We'll see. Yeah, and thanks again, Zach. Con Wolf says, we were having a discussion the other night about a piece of my family history and engineering, a part of the lunar orbiter, which made me wonder, ever consider doing a video combining your favorite things by discussing the history of cameras used by space programs that made so many things possible? Absolutely, Con. That's actually on my list of things to do. that is like literally how. The only problem is Curious Droid just did a video about basically how you take pictures from space recently, and that was like on my list of things to do. Is like, how did they do photographs from space, from deep space, before like, you know, digital cameras really and stuff like that too. There's a really cool history in photos from space, and yeah. We also had some talk about which booster is going to be used for the in-flight abort test. It'll be the 4th mission, if I remember right, for, I think it's like 10, I think, Loopy, I think you're right, I think it's 1048. It's going to be the 4th flight, though. It's one that just launched. Yeah, let's look at post-launch previews. Hang on. Let's see here. What was the most recent Falcon 9, not DM1? Yeah, it was the New Santaru. Teru. It was the one right before DM1. And this is block... Oh, yeah, 1040.3. So it'll be the 4th flight. So it'll be 1048.4. Will be the first. That'll be the in-flight abort, from what I can tell. Yeah, Fell Knight in our Discord says, "Wait, post-launch previews is a thing." Yeah, it's post-launch. They become post-launch reviews once the launch has happened. We keep them up here. Previous launches. Yeah, I guess I call them post-launch reviews now, but I don't know. We could change that. I don't know. So yeah, 1048.4. Yeah. Let's see. Kelly BT, I assumed you watched the Space Council meeting. What kind of role do you think Starship could play alongside, based on what Bridenstine said? So, we're kind of getting into potentially politics land here, but there is still a lot of politics make sure that SLS and Orion survives. That was just proven recently by the fact that they will not do EM1 on commercial providers, which to me is just clearly because it would have been the nail in the coffin for SLS, and SLS would have totally been canceled if commercial providers took over its primary first mission. And to me, until SLS is totally shelved, if SLS were to be totally shelved, I don't think you're going to have a good time to talk. I think Congress would open up to that a lot more if all of a sudden, if all of a sudden they allowed for, bids from other companies to say like, hey, here's what we're trying to get to the moon, this much surface. The thing is, like I said this, I think on a podcast the other day, I don't like when NASA says, here's our mission and here's how we're going to do it. Like, I'd rather them say, here's our mission. You send us proposals and you tell us how you would do it. Because that way, you open up a whole entire spectrum of different companies with different approaches, and they can bid on it, and they can have some of the risk involved then. So their design, if they go too ambitious and say, we can put 30 tons on the surface of the moon, no big deal. We can do it for $2 billion, or else we don't get any money. Like, here you go. Then they're putting their money where their mouth is. And I would love for NASA to say, listen, we really want to have humans on the moon. Here's the guidelines. Here's what we need. And now everyone bid on it. And then I think we would see bids from a lot of companies. And I think obviously SpaceX would love to try to win a bid like that for Starship. I think that would be a huge funding opportunity for Starship. So let's keep going here. Hopefully that answers your question. Ryan Quinn, are you getting a new spacesuit? For now, Ryan, that's really on the back burner for me at this point, just because it's so secondary to anything. I feel like I have a lot more important things to work on. I still am waiting for a certain individual to be able to lend a hand. It's just one of those scheduling things. It's just an absolute nightmare. Someday, Ryan, maybe. But for now, honestly, I know that some people still have an attachment to the spacesuit, but I definitely wore it out for myself. And the only thing the spacesuit would do would be hung up in the background these days. Nathan wants to know, would it be possible to integrate solar panels in the second stage, then recharge the batteries and have them land the second stage back on Earth? Nathan, that's, there's some interesting concepts there. There are some interesting concepts there. it's not going to, the big thing probably isn't the electrical charge, because obviously the vehicle still requires fuel. It's not running entirely off electricity. So the bigger thing that's probably running out at that point is fuel. Electricity is very much secondary. Electricity weighs almost nothing really when you charge a cell. I don't think that they could recharge the battery and have it do any good to be able to land a second stage. And besides that, the second stage is by far the hardest thing to recover because you have to have it be able to survive re-entry first, and that's no easy feat. Look at the space shuttle. Look at just look at a heat shield after it's gone through re-entry. Look at any of the Apollo capsules. They take an absolute beating. So now you have to add all that mass and all that system to an upper stage, and then so what? Now you have charged up batteries, but you're out of fuel. A vehicle that size, I think that vehicle it's the right size to pop parachutes. Because, Falcon 1, Falcon 9, way too big of a vehicle to have parachutes pop and then to have any kind of vehicle come and swoop it up midair. This is way smaller than a Falcon 1 even, or a good amount smaller than a Falcon 1. They could potentially do a propulsive re-entry, pop a parachute, and that vehicle's small enough. It's only a couple tons, I feel like. It's like 2 or 3 tons dry mass or something. It's very light. I don't know the exact number. And have a helicopter actually swoop that one up. It's small enough to do that, and that might be a good reason why it's the size that it is, but that's just totally me speaking off the top of my head. So, yeah, there you go. That's my thoughts on that. Nitro, the 3D motors of the Electron rockets make me curious as to what the cut-off size is from printed it to a traditional built motors. Thoughts? So Nitro, I think for them is a matter of, it's a scale of economy. So they probably found the biggest... of course, there's always literally going to be a price to weight ratio of or price to volume ratio of a 3D printer, even, for something like this. So I'm sure they helped design their engines around the same size of a commercially available, reliable, good, high quality 3D printer like that can make, do it out of titanium or whatever else. So yeah, you can actually scale up. You can make really big 3D printed engines. Relativity is planning to 3D print an entire rocket using a pedestal basically and giant robot arms that feed it's really cool. So you can really, the sky's the limit as far as 3D printing, but of course price comes into factor pretty quickly. So yeah, I think for them the size of the engine is probably pretty indicative of the size of the 3D printer that they could get and having that remain viable. That's just kind of my guess. Kelly BT, sorry, not trying to be political. I just think that the Starship could really be a good way to transport materials and people to the moon. I agree. I totally agree. I think SpaceX agrees. SpaceX is looking at Starship as being a really big fundamental change in spaceflight. And they're betting the whole company on it at this point. They are going all in, putting a huge investments in place to really be able to produce the world's biggest, most powerful, and fully reusable rocket in hopes that it finds customers for things like the moon and Mars and, of course, low Earth orbit missions and geostationary missions. They're hoping to secure they're hoping to just take it all because they're going to hopefully be able to undercut it if you really do have a fully reusable vehicle. Yeah, don't worry. Will Starship have a cargo upper stage? Yes, I believe Starship will have a cargo upper stage. Yeah. Harvester of Sorrow, Kerbal show proposal. See if it's possible to launch complete Orion with a quad booster Falcon Heavy. A quad booster Falcon Heavy does not add that much payload capability, believe it or not. The Orion and service module could be launched right now with a Falcon Heavy, but a quad Falcon Heavy honestly is not that much more capable. You really don't gain as much of efficiency by parallel staging, especially something like Falcon Heavy is already stretching the poor center core to the absolute max. That thing is literally stretched out to the max. So adding 2 more additional boosters really wouldn't help that much because now you're just throttling down other boosters. It might help if, say, they had 4 boosters and the center core now had just a pair of, or 4 medium vacuum optimized Merlins or something different. But at this point, yeah, I don't know. Yeah, I've seen that picture. And I will open this up and show you guys. It is a really cool rendering. It's a really, really cool rendering. But, man, there's a good chance some of us have seen this already. That's really cool. I love that. Countdown clock, get out of there. Yeah, that's beautiful. But again, that's as far as SpaceX already learned their lesson of Falcon Heavy was kind of a mistake in some ways. It's almost too big. They didn't just make the Falcon 9 bigger to begin with. Falcon Heavy definitely pushed them to the limits. They learned that was way more engineering than it was really worth, especially now the Falcon 9 is doing what Falcon Heavy could have done in the first place because they upgraded Falcon 9 so much that it's capable. The Arabsat that's about to launch could be flown on a Falcon 9, but it's flying on Falcon Heavy. Yeah. And Jean-Marc says petrol, electricity money so that you can go watch the Heavy launch and do a meetup with your pals. Well, thank you. Maybe it's Jean-Marc or Jean-Marc. Thank you very much. Yeah, I'll take that. And yeah, we will definitely do, I'll do a meetup for sure for Falcon Heavy. Let me know if everyone, please, if you're in chat right now and you're not going to Falcon Heavy, don't say anything. If you're going to Falcon Heavy, type right now, I'm going to Falcon Heavy. I just really want to see if anyone's going. We'll see. Let's wait. Does this mean nobody, or do I have a good 20 or 30 second delay? There we go. 1, 2 in our Discord. I'm going to Falcon Heavy. Yes. Going to Falcon Heavy. Yes. Going to Falcon. There we go. Wow. Okay. Wow. That's surprising. Okay. That's okay. I'll do a meetup then. I did not realize that many people were going to be going to Falcon Heavy. Someone asked, where is the best place to watch it from? I already have you covered. If you go to, there's a website called YouTube, where to watch a rocket launch, Florida. If you just search where to watch a rocket launch, Florida, I've already got you covered. This is specifically literally about Falcon Heavy.
Can you get my back?
So here you go. Just type in where to watch a rocket launch, Florida. You'll find my video. I tell you all the best places to watch a rocket launch in Florida. Yeah. Yeah. Oh, here we go. Another question from Simone. Do I think 1050 Sealand will be reused? I don't think the booster as a whole will be reused. I think they might use parts of it. They might use some things for something. They might try to repurpose some parts of the engine and things like that. But I don't think they're going to reuse. I thought had they wanted to reuse it, that would have been a good one for the in-flight abort, since it's already kind of a risky mission, or will probably be destroyed anyway. Yeah, Chrono Surter says, let's watch an Everyday Astronaut. Let's watch Everyday Astronaut watch an Everyday Astronaut video. That sounds like bad idea to me. Nobody wants that. Yeah, guys, I think I'm gonna head out of here. It is we've been on for about an hour, so let me know if you have any other questions. You know, if you're, reach out to me on Twitter. Don't forget, if you're not following me on Twitter, twitter.com, just search Everyday Astronaut or type in Erday, E-R-D-A-Y, Erday Astronaut, and ask me some questions. I'm pretty active on there, of course. Check out the web store. We have some new things. We're actually going to be, we have a whole new series and a whole new set coming up really soon that I'm really excited for you guys to see. But meanwhile, you can check out the web store, everydayastronaut.com/shop. If you want some of these, I think next week some of these will be closing out as we make room for new stuff. Again, these are actually printed these days and not just like print on demand. So it's an actual store, which means that we have to make room for new merchandise. So we have some new stuff coming in. So keep our eyes on there often. Look for some closeouts coming up. everydayastronaut.com/shop. Again, if you work in the aerospace industry, click on here to receive 25% off apparel at any time. That's my gift to you for you being awesome and for inspiring me to do what I do. All you have to do is you put in your work email, like at a work address, like at nasa.gov, at SpaceX, at Rocket Lab, and it'll just ping you an email quick with a code. It's not on any list or anything, and there you go. Renau, thank you very much. Yeah, thank you, Renau. yeah, so there you go. That's what's up. I hope you guys are doing well. Hopefully you guys all have. I don't think I'm still gonna have that video out before Falcon Heavy, and I'm gonna stay down there all the way through Yuri's night. So I'm gonna be down there for a while. I'll be scripting. Maybe I'll shoot the Raptor engine video while I'm down in Florida. Because yeah, this is just that time of year where rocket launches are coming up like crazy. It makes it really hard for me to be able to do videos very often. So I'll make time for it. That video, I promise though, the Raptor engine, I'm actually going to release 2 videos at once. It's going to be, so the Raptor engine, we hear a lot about it, but even like, I feel like I'm really intimidated by the Raptor engine. It's hard to appreciate just exactly what it is, what it's doing, why it's special, you know, blah, 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 blah. And unless you know the whole story of rocket engines and the history and have a really wide grasp of context compared to other rocket engines and what this is doing differently, it's really hard to appreciate. So my video on Raptor engines will be giving you a full rundown on other rocket engines and other cycles. I'll be doing a pretty healthy rundown on the cycles, the different engine types. And in doing so, I'm also going to release a video only about engine cycles so that you can watch that separately. And that'll be more broad. It'll have things like the tap-off bleed cycle and a few other, you know, we'll talk about solid rocket boosters and stuff like that in that video. So it's going to be really, really, really in depth. And that's why it's taking me forever. I'm really trying to get it right. I feel like I'm having to grasp a lot of new concepts. I've listened to, I listened to a lot of a book while I was driving around last week. Still just working on it. And I promise it'll be good. So some patience with me. And yeah, that's gonna do it for me, guys. Yeah. Oh, Space in My Head, a new patron member in our Discord. Hi, Space in the Head. Welcome and thank you. Sysman2000 wants to know, when can we order your SpaceX jacket any closer? Yes, that will be coming very soon. Very, very, very soon, actually. I'm releasing that and another spring jacket, hopefully around the same time. I think you'll like both of them. They'll be very cool. Oh yeah, so apparently, even on our Discord channel, some people didn't realize that the featured tab is some stuff. Don't forget, apparel has like a ton of other stuff. And again, these are like actual real things that are in a store already. Yeah, so be sure and click that because apparently people didn't realize that I had like these orbit ones that have. Yeah, we have a lot of stuff here, guys. Don't forget about that. Dad hats, even. We have dad hats now. Do you have a dad hat? Get a dad hat. Well, you got a dad hat. So yeah, that's gonna do it for me, guys. Yeah. Oh, and again, I owe a huge thank you to my Patreon supporters. I know I hopefully I say that enough. They allowed me to be crazy enough to go down to Boca Chica. And I could afford to stay there and stalk Starhopper for a while. I did the stand-up for my Raptor video in front of Starhopper. How freaking cool is that? Yeah, pretty awesome. Yeah. Oh, no way. Sisman was great meeting you at DM1 with your ballerina daughter. Dude, I love your family. That made my day. Tell your family hi. Yeah, it was a pleasure meeting you guys. Really, 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 really. Yeah. All right, guys. Yeah. So again, thanks to my patrons. If you guys want to join our exclusive Discord channel or, you know, hang out and help support, I do go to patreon.com/everydayastronaut. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody. We'll see ya.